Hello everyone, welcome to this question on abstract algebra. This question says, if I1 be the ideal generated by x raised to power 4 plus 3x square plus 2 and I2 be the ideal generated by x cube plus 1 in Qx, then they are saying if f1 is equal to this polynomial ring Qx divided by the ideal I1 and f2 is another polynomial ring Qx divided by this ideal Q2, then which of the following four options is correct, right? So let us get started. So before that, let us have a look at the result. The result says that if Px is any irreducible polynomial, in that case we say the ideal generated by this polynomial is maximal and vice versa. Moreover, if that is the case, that means if we have some irreducible polynomial in the given field over f, that means the coefficients of this polynomial are taken from the field f, then in that case, as we have seen, the ideal is maximal. The ideal generated by this polynomial is maximal, and the polynomial field divided by this ideal, that forms a field. So this is the result, right? So in order to check whether the given f1 and f2 they are field or not, we need to check that the ideal I1 and I2, whether this is an maximal ideal or not. So in order to check that this is an maximal ideal, so I1 is the ideal generated by this x raised to power 4 plus 3x square plus 2. So we need to determine whether this is an irreducible polynomial or not. So let us get started. Let us check whether this is irreducible or not. For checking its irreducibility, what we can do, we can try to factorize this polynomial such that the coefficients are again in this field of rational numbers, right? So now we can think of this polynomial as a quadratic polynomial in x square. So that means we can write it like this. So from here, x square would be equal to, we can use this formula for the polynomial of this kind, ax square plus bx plus c. We have the formula x is equal to minus b plus minus square root of b square minus 4ac divided by 2a, right? So here in this case we would have minus 3 plus minus square root of 3 square, that is 9, minus 4 into 1 into 2 divided by 2 into 1. So it is simply 2. So when you solve this, you will be getting minus 2 and minus 1. So that means the root for this polynomial are x square minus 2, x square is equal to minus 2 and x square is equal to minus 1. That means x square plus 2 and x square plus 1 is a factor. So you can write this polynomial as a product of these two polynomials, and whose coefficients are obviously in the rational numbers. Therefore, this polynomial is not irreducible, in fact, and hence the ideal generated by this polynomial, this is not a maximal ideal. Therefore, the given field, this is the given f1, that is not a field. So f1 is not a field. So this option and this option are cancelled by virtue of this property. So for the second part, we have to check whether the polynomial, the ideal generated by this polynomial x cube plus 1, this is maximal or not. That means we need to check x cube plus 1, this is irreducible or not. So we can clearly see that this follows from the formula of a cube plus b cube. So the formula is a cube plus b cube is equal to a plus b, a square minus ab plus b square, right? So we can obviously factor this polynomial as x plus 1 into x square minus x plus 1. So obviously this is a reducible polynomial and it is not irreducible, hence the ideal generated by this is not maximal, and hence the corresponding field f2, this is not a field. So this option is also this F2 is also not a field. So here we have both F1 and F2, they are not fields. So option D, that is the correct option. Well, that is it for this video. Thank you for watching.